Welcome to episode 6 of this Hoku tutorial series. In the last episode, we talked about normalize, power, and blur divide, 3 deterministic modules that you can use in Hoku. In this episode, we're going to continue with deterministic processing in the form of image math. To understand what image math is doing, you have to understand what a digital image is. Digital images contain pixels, each of which has a value of lightness. Depending on the bit depth of your image, that value would be between 0 and 255 or 0 and 65,535. When you have 2 images, you can perform math to the values at each pixel between the 2 images. For this example, I'm going to demonstrate subtraction. In my case, I have a palimpsest, so an overtext over an undertext. If I was able to get rid of or remove that overtext, in theory, it would be much easier to read the undertext. And that's what I'm going to try to achieve with a subtraction. Subtracting 2 images will emphasize the feature or features that vary between them. So if I wanted to subtract overtext, I would need 2 images, one that has overtext and one that has overtext and undertext. That way, the difference between the 2 images would be just the undertext, and in theory, that would be the only thing showing. So we can see in our image math module, it asks for an input link and an OP link. This is where we will tell it where our inputs are. So we'll take 2 read images, the 2 images we're going to do the subtraction to, and now we need to pick which bands we're going to use. This is when you should reference your triage notes to try to figure out which bands you should use for image math. Ultraviolet or fluorescent images will usually contain both the overtext and the undertext, so I can select one of those in one of my read images. And I also know that an image around 630 or 655 nanometers will contain just the overtext. That's because iron gall ink fades out in the longer wavelengths. So by roughly 630 nanometers, the undertext has completely faded out because it's more faint, it's been erased, and the overtext is still there because it's darker ink. So we can select this band in our other read image, and then we have our 2 inputs to our image math. We need to indicate one of these as the input and one of these as the OP. For a subtraction, the OP link will be the image that gets subtracted from the input link. So here I'll have my input link as the 365 ultraviolet image and my red image as the OP link. For a division, the OP link would be the denominator. It obviously doesn't matter for addition or multiplication. So we can close our image math module and it turns green. We'll also need a show, which I will link to 2 other shows, one that will show us our red image and one that will show us our ultraviolet image. This way, we can see the 2 images before and after the subtraction. We can close up this job and execute to see our results. And this is where we'll get a good idea of what the subtraction is actually doing. Here is our subtracted image. You can see right off the bat that the undertext is very dark. It's got great contrast with the parchment, and the overtext is actually brighter than the undertext. If you look here, this is our undertext underneath the overtext, and the overtext is actually a little bit brighter. And this is exactly what we want. This would be suppressing the overtext into the parchment. And if the overtext was completely gone, that would leave us with just the undertext, which would make it much easier to read. If we compare this result to our 2 input bands, you can see here is our ultraviolet image, and here is our 630 red image. So you can see I did a pretty good job of picking the correct bands. Our red image doesn't really have any undertext, it has only the overtext, and our ultraviolet image has both. So when doing a subtraction to suppress the overtext, you're trying to think what is the difference between the 2 images that I'm subtracting. In this case, the difference is the undertext, because the overtext is present in both, while the undertext is only present in one. That is the difference between the 2 images, and that's why that is really the only element we get in the subtracted image. Of course, because the overtext is directly on top of the undertext, this stuff is always going to be very difficult to read. You're really never going to be able to recover ink that was directly underneath the ink of an overtext. But the closer we can get the overtext to blend in with the parchment, the easier it'll be to make out whatever of the undertext we can in this area of the page. And the overtext has not just improved here, the undertext has as well. You can see it is much darker than even in our ultraviolet image, and that is great. The undertext being darker gives it a greater contrast with the parchment, and that makes it much easier to read. So that's an example of a subtraction. Unlike a subtraction, an addition emphasizes features which are constant between bands. There's no better way to learn how image math works than for you to just experiment and try different operations with different bands to see what's going on. Trying to suppress overtext in a palimpsest using a subtraction or a division is usually one of the best ways to get a good result, because oftentimes the undertext is relatively legible as far as contrast goes, and it's just that overtext that is blocking it out. So that's an example of image math and how you can use it to improve the legibility of an undertext in a palimpsest. And image math is the main form of deterministic processing. These results are still predictable. The more you do it, the better you'll be able to visualize and pick the right bands for different operations. So that is all the deterministic processing we're going to cover in this series. We'll come back to normalize, power, and blur divide later on, but in the next episode, we're going to start with statistical processing. Statistical processing is really the meat and potatoes of multispectral image processing. It's how you're going to produce your best results most of the time. And it's where we can combine all of the steps that we've done so far. That would include our triage notes, our windows or ROIs that we selected, and also I mentioned before the possibility of pre-processing, which is when you do deterministic processing before statistical processing. So in the next episode, we're going to start with statistical processing.